Okay, so now let's see the last event, two examples. So okay, so we want to find that we will use implicit differentiation of to find implicit differentiation to find the example in your textbook to find partial g, partial x, partial g, partial y. If x, y satisfy, x, y, g satisfy this equation, x cubed plus y cubed plus g cubed plus 6xyg equals 1 equals 1. Okay. So in this case, you could, if we say this one, to find partial g, partial x, partial g, partial y, then you could build g is a function of x, y. G is a function of x, y. Okay, this one. And if you remember that in first semester in chapter 2, we have talked about this one by single variable case. I mean, in chapter 2, when we say implicit differentiation, we have talked about this one, something like this one. At that time, we say x squared plus y squared equals 1. And we want to figure out partial dy dx. We want to know dy dx. And x, y satisfy this equation. And how to get this one? If you remember that, and we say, of course, if x, y satisfy this equation, then of course it's a square. It's a circle. Sorry, not square. It's a circle. It's square. Sum of their square equals 1. I mean, it's a circle. Origin is 0, 0, and radius is 1. Yeah. And in this case, you could see actually y is not a function of x. But as we say, when we consider its derivative, we will focus on some point. So locally, you could build y as a function. For example, we want to know derivative means at some point it's slow, right? So at some point it's slow. So locally, you could see that locally it's a function. Y is a function of x. So for this one, you could view it in this way. We could let y be f of x. If you remember that, here we recall. Let y be f of x, then we can get x squared plus f of x squared equals 1. Right? Now, we consider dy dx means that we consider f prime x, this one. So, I mean, here, now all of them are functions of x, so we consider derivative d dx. So, first term becomes 2x. Second term, inside is f of s. F of s is a function of f. And outside is square. So when we consider its derivative, we should consider outside function is derivative. So it's 2f of x. This term is outside function is derivative. But inside function, we should consider its derivative. So it's f prime x. And the constant is derivative is 0. But as we say, we just view y as a function of x. Original, if x, y satisfy this one, y is not a function of x. Just locally, we could view y as a function of x. So finally we should put it back. I mean, 2x will still keep it, but f of x will just replace y by f of x. So now you should put it back. So 2y, and this term is what we want. dy dx equals 0. So finally, what we want dy dx is exactly put it in the left hand side, so it's negative 2x. Right hand side, so right hand side negative 2x, but divided by 2y. So finally, it's y negative x over y. negative x over y. So if you remember that in first semester we have talked about this one. We have talked about this one. So we just recall it here. So now we come to our problem now, our current problem. So now xyz satisfy this equation. So xyz you could view and we want to find partial g partial x, partial g partial y. It means that we could view g as a function of x, y. So now g is a function contains two variables. It's something like this one. Y is a function contains f. Y is a function contains f. So contains x. So g is a function contains x, y. So you could view it this way. I mean x cubed plus y cubed plus g of x, y is cubed plus 6xy times g of x, y equals 1. You could view it this way. So now, of course, if you could know what it means, what it really means, then you could skip this step. You could skip this step. Yeah. Otherwise, if you see it would better, you could write it in this way. Okay. So now you can see that partial g, partial x. So now all of them contains two variables, x and y. So now we can see that partial g, partial x. Partial g, partial x, it means that we consider its derivative with respect to the variable x. So now we will let y be view y as a constant. So now y is a constant. This term is a constant. Okay. So first term, its derivative is 3x squared. And the second term, y cubed now is a constant. So constant is derivative 0. And the third term here is inside. Here is outside. Here is inside. So third term, outside function is derivative 3 times g xy. And now put it down, so power subtract 1, so it's 2. So it's outside function is derivative. Multiplied by inside function is derivative. Inside function, the function g contains two variables, x and y. So we can see, so now we can see the partial g, partial x. Yeah, and it's what we want, partial g, partial x. This one. And the plus, now this term is derivative with respect to the variable x. So 6y, all of them are constant. So 6y we could take out. 6y are constant. 6 and y, they are constant. We could take out. So now we still have g times g, x times g, xy. These two terms, they are product. So now we can see a product of these two functions, their derivative. So their derivative we should use product rule. So first term is derivative, x is derivative 1 times g xy plus x times second term is derivative is what we want, partial g, partial x. This one. Don't forget, for the right hand side, constant equals the right hand side constant is derivative 0. So we have this equation. Okay? And in this equation, what we want is to rewrite this term. Actually, it's what we want to know. We want to know these two terms. So we should organize it. So, but here, actually, the function g is exactly, we just rewrite it by this way, but actually they are the same. So so you should put it back, so you could simplify this equation. 3x squared plus 3g squared times partial g partial x. It's partial x plus partial g plus here we could use the distribution. So you will get 6yg plus 6xy times partial g partial x equals 0. So partial g partial x, both of them have the term partial g partial x. So we could combine them. And put it in the left hand side. Combine them, so it means we take out the common number partial g partial x. So we still have 3g squared plus 6xy equals, for the rest two terms, we put it in the right hand side. So negative 3x squared subtract 6yg. So finally, what we want to figure out is partial g partial x is exactly negative 3x squared subtract 6yg over 3g squared plus 6xy. So yeah, it's exactly this way. Okay. And then for partial g partial y, you will be senior. So for partial g partial y, we could start directly from this equation. You will be senior, so actually we start from this equation directly. Partial g partial y. As we say, just view g as a function of xy. So, and then when we consider the variable is y, then x is constant. So first term is 0. Second term, y is inside. So now what derivative of y cubed with respect to the variable y, then is 3y squared plus g. G is a function of xy, so 3 we put it down. Also, it's something like this term, g cubed. But now the variable is y, so for this term we could put it here, but just replace x by y. So it's 3g squared times partial g partial y. It will be similar, just replace x by y. For this term, just replace x by y. Yeah. The next one is, here we have the variable is y, so 6x is a constant. So 6x is constant. So our variable is this one. I mean, it's a function of it's a product of two functions, y and g. Both of them have the variable y. So product rule. First term is division 1 times g plus y times partial g partial y. This one equals 0. And then use the distribution again. So here we have 3y squared. You see that? Yeah. 3y squared plus 3g squared partial g partial y. And distribution 6xg plus 6xy partial g partial y. This one. And partial g partial y, both of them over here. And then we put it the left hand side, partial g partial y equals, so for these two terms, put in the right hand side. Negative 3y squared subtract 6xg. And the left hand side we combine these two terms. Both of them, since both of them have the common number partial g partial y. So in left hand side is 3g squared plus 3g squared plus 6xy. This one. And then put in the denominator, finally we can get partial g partial y equals negative 3y squared subtract 6xg over 3g squared plus 6xy. This one. Yeah. So it's the question use the implicit differentiation to find partial g partial x, partial g partial y. Yeah. Actually for this problem in section 11.5 we will give another formula to solve it. Yeah. way to solve it, another way to solve it. But here actually we could solve it now. Just use just use the definition about partial derivative. Yeah, we could solve it. Okay, and we still have one more example. Here I erase mostly. Oh, it's not very. Okay, yeah, so let's see one more example. Yeah, if the function w is this one, square root of u squared plus v squared. Yeah, so you will see w is a function of two variables, u and v. And we want to figure out wv, wvu. This time it means that we consider its derivative with respect to u firstly. And after that, we consider the partial derivative with respect to v, and this time is wv, wu. Yeah. And of course, you could figure out all of another second derivative. I mean wuu, wvv. You could figure out them. You also could figure out these two terms. Yeah. But now we want to know these two terms. Okay, so now let's see the function w. So w is the function square root of u squared plus v squared. But we want to consider its derivative with respect to u or v. Anyway, so it will be better to rewrite it by this way. And then now we know that it's inside. We want to consider its derivative, so we use this way again. It's an outside function. Outside, inside, outside. So its derivative with respect to u, then we could view v as a constant. V as a constant. But outside function, but for this one we should use the chain rule. So outside function will put it back. So it's u squared plus v squared. Outside function for its power we should subtract 1. It's the first term. For the outside function is derivative. But inside function we should consider its derivative. So inside function is derivative. Variable is u, v is a constant. So it's, for example, u prime plus 2 squared. Then its derivative is 2u. Then its derivative is 2u. Then its derivative is 2u. Yeah. And here, wv, of course here we could cancel it. So it's u times u squared plus v squared. 1 half subtract 1, so it's negative 1 half. This time, negative 1 half. And the wv, what's this? Wv is, now outside again, outside function, put it back, u squared plus v squared. 1 half subtract 1, so it's still negative 1 half. Times inside function is derivative, but now variable is v, u is a constant. So it's something like 2 squared plus v squared. It's derivative. So constant is derivative 0 plus 2v. So it becomes is 10. For the second 10 is derivative. For inside function is derivative is this one. And we still cancel it. So we still could write this way. I mean it's 10. Negative 1 here is 10. Is 10. This way. Okay. And now all we want to figure out is WUV, this one. So for this term, we can see its derivative with respect to the variable v. Then u is a constant, so just this term we have the variable u, variable v. So u is a constant, so we could put it back. And then for this term, its derivative now it's inside. It's outside, and this one is inside, it's outside. So its derivative, put back negative 1 half times u squared plus v squared to the power of negative 1 half subtract 1, so it's negative, okay, negative 1 half subtract 1 times inside function is derivative, but now the variable is v. The variable v, so it's 2v. It's 2v. It's 2v. V. The first 10 is just constant, keep it. So we have 3 tens. This one. This one. Okay. Yeah, and still could cancel it. So finally it's equal to uv, negative uv times u squared plus v squared to the power negative 1 half subtract 1. 1 is 2 over 2, so it becomes negative 3 halves. 3 halves. This one. Okay, and then WVU. WVU should start from this one. So for this term, we can see its derivative with respect to the variable u. Then this term, v is a constant, keep it. And then outside boundary, put it down. Inside function keep it, and negative 1 half subtract 1, negative 1 half subtract 1, multiplied by inside function is derivative. So now inside function is derivative, but the variable u, so v is constant, so it's 2u. It's 2u, so we have 3 tenths. This 3 tenths. And again, cancel it. Still have the negative sign, so it's negative uv, negative uv times u squared plus v squared, negative 1 half subtract 1, so it's again the same, negative 3 halves, negative 3 halves. And as we said, of course, you could check WUU, you could check WUU, WVV, check it. But here, we want to figure out these 2 terms. And in this example, you will see. What's this? WV this one. It's exactly equal to this one, right? It's exactly equal to this one. So yeah, and actually it's our the last proposition. Or the last area. Just indeed we have this result. So suppose f is defined on a disk D, and AB, the point AB belongs to the disk D. Then if the function f it has 2 variables x and y. I mean, on this D is on R2 space, so it has the 2 variables x and y. So if fxy, consider first derivative with respect to the variable x. Consider fx firstly, and after that consider y. And fyx, if these two second derivatives are continuous on the disk. If these 2 second derivatives are continuous on the disk, then what can we say? You will have the same result. The general result is that they will be the same. Fs1AB is always equal to F1XAB. We have the general result. Okay. So indeed, for this example, indeed, we will see these two terms. Actually, they are the same. Okay. Yeah. So I think it's all the material in section 11.3. Section 11.3 is basic important result in this chapter.